XSS, or cross-site scripting attacks, are a very common way to attack a web application that utilizes JavaScript or similar languages. And typically it occurs when we're taking data from the user and outputting it to the screen in some sort of way. Now that input can vary in a lot of different ways, sort of similar to things like SQL injections. The locations that you can get those sort of inputs from are very varied, right? They can come from input boxes, they can come from cookies, they can come from database information that is provided by the user. They can come from files that are uploaded from the user and like the names or the data contained inside of the files. So it's one of the vulnerabilities that are very common in web applications and very easily preventable just by not trusting user input and filtering out vulnerable characters and not executing essentially user input as code. And that's essentially the theme of what this is all about. When you have cross-site scripting vulnerabilities available inside of your application, they're available because we execute user input as code, or we write it to the page in a way that it can be interpreted as code. So we never want to allow those sort of situations to happen, and we'll discuss a few different ways that we can prevent this. But first, we'll take a look at a few different ways that we can find these vulnerabilities and what they actually do. So we're going to start off with what is called a reflected XSS attack. The idea of a reflected attack is that it's not stored somewhere in the web page. What you have to do is you have to convince someone to input the vulnerable input, or you have to perhaps provide them with a URL that will do the input for you, or you have to send the packets in some other way. So you aren't able to actually just like store it somewhere and anyone who visits gets attacked. This one is one that has to do with people actually inputting the input themselves. So let's go ahead and access the lab and let's take a look at the information here. Let's give a minute to log in. So essentially what's happening in this blog is when we search for something, say test, you'll see it says results for test, right? If we go ahead and inspect the element here, we can see that it writes whatever we wrote into this header here. So we are able to essentially write whatever we want into this header, which means that we can actually write JavaScript code. So for example, if I pipe in something like this, so script alert 1 script. What this does is the script tags tell the browser that we're going to have some JavaScript. We put the JavaScript code here, which is an alert window that will pop up the number 1, and then we end the script tag. When we search for this, you'll see our alert pops up on the screen. This is a perfect example of a cross-site scripting attack. When we input JavaScript code, rather than it displaying the information to the screen, it actually executes it as code. So we press OK here, and I'm just going to show you what this actually looks like in the code so you can get a bit of an understanding. So you can see here 0 results 4, and then it has our script, right? So you can see that it executes our script inside of the header, and it gets interpreted actually as JavaScript rather than get interpreted as text. So the question would be, how can we prevent something like this from happening? The first way to prevent something like this from happening is to not allow for specific types of inputs. So, these angular brackets, for instance, we can try to avoid those inputs. We can remove semicolons, for instance. We can remove closing tags. That sort of idea is something that we can do to be able to help filter out some of that data. There are also specific ways to filter out the actual inputs themselves to sort of escape those characters. So whenever you see an opening brace, for instance, you can add the escape character for the opening brace and closing brace to those. A lot of the time these are done through actual frameworks in JavaScript or related languages that will allow it to actually filter out those values before they're actually inputted. So that'd be the example of how we can sort of prevent this sort of thing from happening. But this gives you some intuition behind how this sort of attack can happen on a basic level. When we take a look at the other types of attacks, you're going to see how we can do it in a bit of a more complex way, but a way that does a bit more damage. With this example here, we would have to convince somebody to search the blog for that specific input, or we would have to send them a URL that has this in the search. If we were to do something like that and the person accesses it, it would execute our cross-site scripting code, and there's a lot of different things that could happen from there. One of the most common things is that we can steal the cookies from the browser. That means that we can typically authenticate as the user utilizing their cookie. So that's one of the most common things that typically happens. Csrf attacks are very common with cross-site scripting, and there's a lot of other different attacks. Basically, anything that you could do through JavaScript, you can do with these cross-site scripting attacks. So when we have these sort of situations where you have to convince the user to go to a specific URL or input something specific, it's actually a bit harder. One thing that I will point out here is that there was a very big set of these attacks that happened, it was maybe 5 or so years ago. And essentially what happened is inside of the console, attackers were convincing users to type in specific sets of code promising that they would do something. Maybe like expose some secret portal that they could like change specific settings, or, you know, any sort of lie that you can give them to convince them to do that. What that actually did typically was send the cookie to the attacker so they could authenticate as the user and essentially hack their account. So that console input is another great example of this reflected cross-site scripting. You'll actually notice if you go on pages like Facebook or Discord, for instance, if you open up this console, you'll see a big message there that says, do not input code into here. If you're being told to input code into here, you're probably being scammed. So it was big enough that all of the major sort of companies started to put that information in so you could see that you shouldn't input code in there. So that's another common example of a reflected cross-site scripting attack. We're going to take a look at a stored cross-site scripting attack as well. These ones are a lot more dangerous, and these sort of attacks have happened a fair amount of times. One of the biggest ones that I remember is back when YouTube was sort of in its infancy and starting up. People were able to put cross-site scripting into the comments section. So you would go to the comments of videos and they could redirect you to random sites, or they'd be popping up GIFs and all sorts of weird stuff. That happened quite a while ago, but it was something that was quite big. If you were on YouTube at the time, you probably remember seeing that. And that was a result of stored cross-site scripting. And a lot of other web pages have fallen victim to this. A lot of others are still falling victim to it. I've personally found a lot of these in the products that I've investigated through my career. It's very common to find these cross-site scripting attacks. They're just very common oversights from developers. So let's take a look at how this differs from the previous one. When we access this lab, what we're going to do instead of going to like the search or anything like that is we're going to go into the posts. And inside of the posts, you see that we can leave a comment. Now, if we're going to investigate some of these comments, we can take a look at them and see what they typically look like. And you can see inside of the paragraph, we just print out whatever the user put inside of there. Whenever we see situations like this, we should be thinking to ourselves, okay, this is a perfect location to try to do a cross-site scripting attack. So let's go ahead and give it a try. Like before, we'll use the exact same setup. We'll do script alert 1. So again, like this. And for the name and all of that, we don't really care what we put in here. It doesn't really matter. And we'll go ahead and post our comment. You see when we do and we go back to the blog, you'll see it pops up with our alert, right? The difference between this and the reflected cross-site scripting is that anybody who visits this page, no matter what, is going to execute our code. So this is a publicly facing one. We don't have to convince the user to do anything special to hit this vulnerability. All they have to do is simply visit the vulnerable web page and they'll get hit by it. This is, again, extremely dangerous because there's no need to convince the user to take some sort of action. No user interaction escalates the severity of this greatly, because anybody who visits this site and has the misfortune of coming to a page that we compromised is going to get attacked by us. So we can execute our payload against almost anybody who accesses this site, unless they have like JavaScript disabled or something like that. So this is another sort of example. And again, the idea of it is very similar, very straightforward. The very last one that we'll take a look at is a DOM-based XSS. And the idea of this is that when we are working with JavaScript, sometimes we concatenate the user's input into a very specific location. And when this happens, we might need to actually escape out of that and then execute our code rather than executing it immediately. I'll give you an example. Like if we give an input and it lands in the middle of an array, for instance, we might need to like close off the quotation and then close off the array and then run our script. Or we may need to do something slightly different. There are a few different tricks that we can use, such as onload, for instance. What we can do is we can put in HTML elements and say onload do this, or even on error. On error is typically the one that you'll see. We could do an image and try to load something and say on error execute this JavaScript, and that will always allow us to execute the code rather than having to jump through hoops to close off the bounds or anything like that. So with this example here, it's relatively similar to the first one that we took a look at. Again, we have our search here. And when we search, our content does get written to this page here, right here. However, it's not really something that we're able to attack. But there's more locations where we could potentially attack, and it would be right here. You see that this tracker.gif has the search terms inside of it. So we can actually attack this specific section here. And what we can do is we can sort of close off the image tag, and then we can put in another tag that will be able to execute our code for us. So the question is, how can we do something like that? Well, if we want to close the tag, we can put a double quote and then a closing tag here. So see, that would do search terms equals a closing quote, and then it would close off the image tag. And then what we can do is we can open up another tag, and then we can create another tag that's sort of like of our definition. So what you do here really doesn't matter. You could do like image tags. You could do any sort of tag here that will have sort of these features available in it. So as an example, we could do an SVG. An SVG is just like an image tag, right? We could say on load equals alert 1. So again, what this does is it closes off this image tag, and then it defines a new tag that just is an SVG. It has an onload property that executes the JavaScript that we put in here. So essentially, it closes off the first tag, it loads our new image, and as long as the image loads, it will alert us with that JavaScript alert. So we can go ahead and do this search, and as you can see, it executes our code. Now, let's go ahead and take a look at what this looks like to understand a bit more. So you can see here, here's essentially the piece that we have. So you see we close off this tag here, and then we have our SVG onload here, which is the piece that we injected in. So you can see that we just sort of like close off the tag. We create a new tag that when it loads will alert, and then we're done. Now, there are, again, other ways to do this. On load is one. On error is another one that's very common. On hover is one that's quite common as well. So you have to take into account that HTML elements can have JavaScript embedded in them too. So the key takeaways here are essentially the following. Whenever we print information to the screen that is provided by the user in any way, we have to make sure to sanitize that input in whatever way that we really can, whether it be escaping specific characters, whether it be avoiding certain characters altogether, whatever option you want to pick, whatever one's most appropriate for your application, you want to make sure that you're applying it. The second key takeaway here is that JavaScript is not the only location that's vulnerable. If you have HTML elements that are being written, you can actually execute JavaScript through a lot of them. Specifically things like image tags, things like hrefs have on load, on error, on hover. You want to avoid being able to write those pieces, again, by either filtering out like on load or that sort of thing, or filtering out the brace brackets, or just like preventing specific characters, whitelisting certain things. There's a lot of different methods that you can use to prevent this, but those are the key areas where you're going to see those attacks. So this gives you an idea of the 3 main XSS based attacks. And it gives you a bit of an idea of how they really look, what they look like in the source code, and what you should be looking out for in terms of preventing them. So remember that HTML and JavaScript are the 2 main areas. If you're writing HTML and JavaScript from the user, even like PHP echoes or anything like that, if you ever take something from the user and write it to the screen, you want to make sure that you aren't vulnerable to this vulnerability by using some of the same methods that I showed you here, by like writing a script that alerts 1, for instance. If you do that through your inputs, you'll be able to easily tell if you're vulnerable to this sort of attacks. So this should give you a good idea of how to locate these sort of attacks and prevent and patch them in your own web applications.